Hi guys, welcome to Inequalities 2. We're going to continue in this video the basic rules that we started off in the first session, that is the introduction session. And we're going to see some more cases, some more rules, and what is the reason why these rules exist. Okay, let's start with taking squares on both sides. So in the last video, we have seen what happens when you're sending terms to the other side. We have seen multiplication and division on both sides. We have also seen inversing, and we have seen some interesting results. Now, we are going to start this video by looking at squaring of things on both sides. Now, if you want to square things on both sides in a simple equation, things are easy. If I say 2x equal to 5, you will square and say 4x square equal to 25. Nothing is wrong in this. The problem on inequalities side, or when you're dealing with inequalities, is slightly different. Let me give it to you with a numerical example. If I say 2 is greater than minus 3, when I square it, you can't keep the sign sign same, because when you square, you will get 4 and it's actually going to be less than 9. Correct? However, if I say minus 2 is greater than minus 3, now when the sign changes, or when I square it, you will get 4 is less than 9. So the changing of sign, and then you look at the positive when both of them are positive. Let's say you have 4 is greater than 5, or rather, sorry, 4 is less than 5. So 4 is greater than 3. Then you'll get 16, sign will remain. 16 is greater than 9. So here, when you're squaring things on both sides, you have to be careful. I have given you two examples where the sign is changing. I have given you an example where the sign is not changing. So how do you make sure whether sign is changing or not? This depends upon the knowledge of what is happening on the left hand side, or what value you're dealing with on the left hand side and the right hand side. Now, if both are 0, so let's take the first case. Let's take it into cases. Case 1. Both LHS and RHS are negatives. Then let us see what happens. If both are negative, then as I clearly showed, you have a minus 5, which is greater than a minus 7. So when you square it, you will get 25, but this will be less than 49. So when both are negative and you're squaring, the sign will change. Case 2, in fact, I will add it in case 1 itself. Both are positive. If both are positive, what happens? Or let's call it as case 2. Both are positive, which means I have 5 less than 7. So when I square it, I'll get 25, still less than 49. So if I know both are positive, then my sign will not change. This is my second case. The third case is when one is positive, the other is negative. And here the problem comes. Case 3. Now here, observe the problem. When I write 3 positive number, any negative number is always less than a positive number. Look at two cases. I'm giving you two cases here. 3 is greater than minus 10 and 3 is greater than minus 2. If you square this, what do you get? You get 9, but it has to be less than 100. If you square this, you will get 9, but it is greater than 4. So you can't say blindly that if they are opposite sign, that is one is positive, one is negative, the sign will always change or always not change. It doesn't work that way. I've shown you. In one case, the positive side is turning out to be less. That is the first case. And in the other case, the positive side is turning out to be more when you square. So ultimately, it depends upon the magnitude of the numbers, because basically the logic is when you square something, this negative sign is gone. The negative sign is gone. So the one single point you have to remember, for whether you call it case 1, case 2, case 3, any of these, one single point is the squaring and thereby the sign finally, the greater than or less than, which side it is. It depends upon the magnitude of what you're taking, right? If you start with the magnitude of, here if you notice in the first case, -7 magnitude is 7, which is greater than magnitude of -5, which is 5 itself. Magnitude means, for those of you who do not know, magnitude means without the sign, the number without the sign. That is called as a magnitude. So 7 is greater than 5, so ultimately 49 will be greater than 25. Whereas in the second case, magnitude anyway is, I'm starting with 7, and anyway 7 is greater than 5. So it will not change. Ultimately the sign is the same. Whereas in the third case, starting point is positive greater than -10. So positive 3 greater than -10. So I am starting with magnitude of 10, which is actually greater than magnitude of 3. But the 3 is greater than -10. So when I square it, it will get back into this form. 10 is greater than 9. So this is what you have to take care of when you're squaring. So once again, which means when you have x is greater than y, you can't, the point is you can't blindly square. You can't do this without knowing what is happening about x and y. Please keep this in mind. All right, so the next thing is what happens. We'll do the next thing, which is taking roots or higher order roots. Oh, by the way, there's one interesting fact for the previous one. If you take higher power, what happens? Higher power is interesting and more confusing. If you notice, you have -2 is greater than -3. When you square it, you will get 4 is less than 9. But when you cube it, you will get -8, but again greater than -9. -27. So you can see that squaring it is changing the sign, cubing it is again changing the sign to the original. So this is, you have to be careful about squaring things or taking it to the higher powers. Okay, keep it in mind and don't by heart everything. You don't need to by heart what happens when both are positive, what happens when both are negative. Don't by heart it like that. Just use common sense. See that these are the various possibilities that can exist. Which power are you taking? Is it a higher even power or the odd power? Even power means the negative sign goes away. Odd power means the negative sign stays. So if you are raising something to the odd power, the sign will remain as it is. It will not change because the negative will always be there. Okay. Well, going forward, like now looking at the roots and higher order. So if you look at roots, first of all, to take a square root of a number, square root of a number, you have to make sure that it is positive. Otherwise, it is not real. It is an imaginary. So at least for the square root part, we are dealing with both sides positive. So if I have 4 is greater than 1, then root of 4 will also be greater than root of 1. So basically you'll get 2 greater than 1. So the sign will remain. The sign will remain as it is. It will not change. 2 is greater than 1. Obviously, you don't ask what is happening when I take a square root of a negative number because it gets into the complex domain. So we are dealing with real numbers. Okay. What about higher orders then? Higher order things. What happens? Higher order roots means, let us say I have -8 greater than -27 and I want to take power 1/3. So if I take cubed root of -8 and cubed root of -27, will I keep the sign same? Let's see. This gives you -2. This gives you -3. And you can definitely say that the sign remains the same. So higher odd powers, the sign will remain the same. Even powers, first of all, cannot be taken for negatives. That much you know. So if you're talking about even square roots like 4th power, 1/4 to the power of 1/4 or square root and so on and so forth, even powers, then obviously both sides should be positive, and then it gets back to the previous example of your 100 greater than 169, sorry, less than 169. So you will get, if I take square root, you'll get 10 less than 113, 13. Yeah. So the sign doesn't have to change here. Okay, so keep a look of these things. Make sure that you don't blindly follow taking roots and higher order roots. The next thing we're going to talk about is comparing a number with higher powers of itself. This is interesting. This is something very nice that you need to notice. Let's look at 2 and 2 square. Clearly 2 square is greater than 2. And if I take higher power of this, you will get 2 cube, which is again greater than 2 square. So when you start with a positive number, x, if x is positive, so if you have x is greater than 0, then you will have x is less than x square, which is less than x cube, which is less than, okay. Right, so comparing a number with higher power of itself, it's very interesting. So let's take an example. If I start with 2, I take a higher power of 2, which is 2 square. So clearly I know 2 square is greater than 2. 2 cube, I know 2 cube is greater than 2 square, and so on. So if you know that x is greater than 1, and you will see why am I saying 1 and not 0. When x is greater than 1, you will get x will always be less than x square, will always be less than x cube, and so on. Because the higher the power you take, the bigger the value becomes. The magnitude gets amplified. However, observe this. When x is between 0 to 1, when x is between 0 to 1, let's take an example and find out what happens. I will take 0.5. When I square it, what do I get? I get 0.25, which is actually lesser than 0.5. So 0.5 is greater than 0.25. If I take cube of it, I'll get 0.125. So the observation here is when x is a fractional part between 0 to 1, then the higher the power you take, the lower the value becomes. So in such a case, you will get x is actually greater than x square because the value decreases when you square, actually greater than x cube, and so on. This is something which you have to keep track of. So again, when you're dealing with variables, you can't always say that higher power of x will always be greater than x itself, because we see that when x is greater than 1, it behaves in one way. When x is between 0 to 1, it behaves in a different way, opposite way. Now, what happens when x is negative? Let's take a look. When x is negative, so let us say x is between 0 and minus 1. So let's take a fractional value of x. So let us say I deal with minus 0.1. When I square it, you will get 0.01. When you cube it, you will get 0.001. But basically, whenever you take even power, it becomes positive. And when you take odd power, so the negative part I forgot, when you take the odd power of it, the magnitude falls. So actually, if you compare these two also, what happens? You get minus 0.1 less than negative 0.001. So you'll start noticing that when it's negative, it's not a straightforward thing. It depends on what power you're raising. Even powers will always be positive and greater than the negative powers, odd powers. And odd powers also, when you're trying to compare, the higher the odd power, the smaller the magnitude becomes. The magnitude is smaller and the number is negative, basically means this will become greater. So you can actually say x will be less than x cube, will be less than x power 5. So whichever odd power you're taking, this power 1, it will always be greater than the previous odd power, lesser odd power. And if you're taking even power in this, please remember this is true when you're dealing with this particular range. So when you have x even or power even, what happens then? You will get x square. Remember, x square is 0.01. What is x power 4? X power 4 is 0.0001. It is becoming even smaller. So you will get x square greater than x power 4, greater than x power 6, and so on. And all of them will always be greater than the odd powers. All of them, because these are all positive and these are all negative. So anyway, positive is always greater than negative. So this is something, again, things to be kept in mind. And of course, when x becomes greater than or lesser than minus 1, so when x is in this range, x is lesser than minus 1, then let's take an example of minus 2. When you square it, it becomes 4. When you cube it, it becomes minus 8. power 4 becomes 16. After that becomes minus 32 and so on. So you can see that these values, this will become, this is x power 1, x square, x cube, x power 4, x power 5 and so on. So you can see that x power 1 will now be greater than x cube. It will be greater than x power 5 and so on. So the reverse is happening here compared to what we did earlier. Whereas in terms of x square will be less than x power 4, less than x power 6 and so on. So basically whatever happens between 0 to minus 1, the reverse is happening after minus 1. Same thing we have seen between 0 to 1 also. Whatever is happening between 0 to 1, positive side, the reverse will be happening after 1. This is what happens when you're dealing with higher powers and raising the number to a higher power of itself. And the last part for today's or this particular session is the number line. I'm sure quite a few of you know, but I'll introduce the concept of number line. What is this number line? Number line is nothing but a line, horizontal line drawn. And for a lot of practical purposes, it is the x-axis with 0 being in the middle. You have positive values on the right side and negative values on the left side. And usually the number line is drawn to find the combination of inequalities and their answers. Okay, so if I say plot or what is the answer when x is greater than 6 and x is less than 5 or x is less than 10. So when you want to use a number line, you have to take 6, 10. First plot the x greater than 6. So cover all the area greater than 6. That is in red color. Now plot the area x is less than 10. X is less than 10 means this entire area is less than 10. Now and we're going to discuss and also and or also very detailed in the next video. But right now and means combination. Combination means what is common for both. Common for both is the area where both red and green lines intersect. And you can see that the area is this. So it is between 6 to 10. So x is less than 10, but it is greater than 6. You can see this. This is your x. And since 6 is not included, 10 is also not included because less than 10 and greater than 6. The final answer also 10 and 6 are not included. That's why it is only less than and less than, greater than 6 and less than 10. Okay, this is how we use number line. So we're going to take up a lot more uses of number line. We're going to use number line quite a bit when there are multiple x's to be converged. I showed you an example using only 2 of them right now. But what happens when I have 3 different conditions or 4 different conditions? How do you find it? That's what we're going to see in the upcoming video. All right. With that, I'll end the session here. I hope you liked what I'm discussing. Please feel free to leave your comments and I'll make sure that I address all your queries. Thank you guys. See you in the next video.